Welcome to True Projects. In this video, we are going to explain about a project titled Inverse Cooking Recipe Generation from Food Images and Cuisine Classification. The introduction of this project is to create a novel system for generating the cooking recipe and classifying the cuisine using the food images. To achieve this project employs the ResNet 101 model for cuisine classification and LSTM for recipe prediction. The challenge lies in accurately identifying the cuisine name and ingredient details solely from images of the food. The models are trained on the large data set and the performance is evaluated against other algorithms. The goal of this project is to leverage the deep learning methodology, specifically the ResNet 101 model for the cuisine classification and LSTM for recipe prediction to generate the precise cooking recipe and categorize the cuisine based on the food image. Through training these models on an extensive data set of recipes, the objective is to create a system capable of automatically recognizing the type of cuisine and generating the comprehensive recipe details from images of the food. This system aims to offer valuable support in the culinary field by providing accurate and helpful information. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDEL with version of 3.7. These are the modules that are implemented to build this project. The first module is Upload Recipe Dataset. In this module, the dataset containing the information and their corresponding recipe details will be uploaded. The images and recipe information will be read and processed. Additionally, a TF-IDF vector will be constructed, capturing the average frequency of each word occurrence in the recipe test. And the second module is Build ResNet 101 model. This module involves training the ResNet 101 model on the food images from the dataset. The model will learn to classify the cuisine type based on the visual features extracted from the images. Simultaneously, the LSTM model will be trained on the TF-IDF vector, which contains the recipes of the details. The prediction accuracy of the trained model will be calculated to access their performance. Train the SVM and XGBoost algorithms. In this module, the SVM and XGBoost algorithm will be trained using this dataset, and these algorithms will learn to classify the cuisine type based on the provided features. The prediction accuracy of both algorithms will be calculated to evaluate their effectiveness in categorizing the cuisines. And the fourth module is of Upload Image and Predict the Recipe. This module enables the user to upload a test food image. The ResNet 101 model will classify the cuisine type of the uploaded image, while the LSTM model will predict the ingredients and provide the recipe details. This model combines the prediction from both the models to generate accurate recipe information based on the input image. And the final module is of Comparison Graph. In this module, the prediction accuracy of all algorithms be calculated and plotted on an accuracy graph. This graph allows for a visual comparison of the performance of each algorithm, providing the insights into their effectiveness in classifying the cuisines and predicting the recipes. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files, the dataset folder consisting of 1 million dataset, and the image folder consisting of different images within it, and the model folder consisting of H5 files and NPY files. These files can be loaded into the project code during the runtime to utilize the trained model for various tasks, such as making predictions on new data or performing the specific operation. And the test images dataset consisting of the various images which is used for testing the model, and this is of NPY file, which is also utilized the training model for various tasks, and the main and recipe are the Python file, and this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this we are interacting with the program. First we need to click on upload recipe dataset button. With this we are going to import the dataset, that is 1 million named dataset, and then click on open button. By this the dataset is loaded and recipes data is loaded, and then click on build ResNet 101 model. By this, the model is generated by using the recipe dataset, and then gives an accuracy of 99%, precision of 99.8, recall of 99.8, f-score of 99.8, and then click on Train SVM and XGBoost Algorithms button. By this, the SVM algorithm is generated by using the recipe dataset, gives an accuracy of 57%, precision of 45%, and recall of 50%, f-score of 46%. In the same way, the XGBoost model is also generated by using the dataset of giving the accuracy of 12.5, precision of 5.8, and recall of 7.5, and f-score of 8. And then click on upload image and predict the recipes button. By this, it is redirected to the test images folder, and we need to select any one of the images that are present in this data folder, and here I am selecting of the second image and click on open button. By this, the cuisine classified as delightful Indian coconut vegetarian curry, and then close this image. Here it gives as recipe name and ingredients we used in this cuisine, and the cooking details how to prepare it in this way, and the nutrition details of how much nutrition and what are the calories what are present, fibers and of fat amount, and many more that are present in this cuisine. In this way we can generate the inverse cooking recipe from the food images and the cuisine classification. The implementation of ResNet 101 model for cuisine classification and LSTM for recipe prediction has shown the promising result in generating the accurate cooking recipe and classifying the cuisine from food images. By leveraging the deep learning technique and training on a large recipe dataset, the system has demonstrated its ability to accurately identify the type and provide the detailed recipe information, offering the valuable support in the domain.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.